Hello students, hello everybody. This is Pradip Sir once again. As you all know that we were doing the chapter a pair of linear equations in two variables from class 10 mathematics. Now today I will show you another type of linear equation which are not in the form of pair of linear equations in two variables. So first we have to convert them into a pair of linear equations into variable, then we can solve it. So equations reducible to a pair of linear equations into variables. Let me show you one equation. This is from exercise 3.6 of NCERT book class 10 mathematics. The equation is 2 upon root x plus 3 upon root y is equals to 2, the first equation, and the second one is 4 upon root x minus 9 upon root y is equals to minus 1. So it is clear, as you can see, that they are not in the form of linear equations into variables. So first of all we have to convert them, change them into linear equation, then we will solve it. So how to do that? It is very simple. Let us take, let 1 by root x equals to u and 1 by root y equals to v. 1 by root x means 1 upon root x is u and 1 upon root y is v. Let us replace these values here. So the given equation number 1, this is equation number 1 and this is equation number 2. Now what change is observed here? It is 2 upon root x, but 1 upon root x I have taken as u. So this equation, the given equations, will become, or better write down, the given equation becomes, what change will be observed here? 2, this 2 upon root x can be written as 2 multiplied by 1 upon root x, but this 1 upon root x I have taken as u, so this will be written as 2u. Similarly 3 upon root y can be written as 3 multiplied by 1 upon root y, but this 1 upon root y I have taken as v, so this will change into 3v. Understood? Hope it is clear. So the given equation, this 2 upon root x will become 2u, 3 upon root y will become 3v equals to 2. This will be equation number 3, and this is 4 upon root x is 4u minus 9 upon root y is 9v equals to minus 1. This will be equation number 4. Understood? Now see this. This is in the form of a pair of linear equations in two variables. U and v are the variables. It was x and y there. Now it is u and v. Okay? So let us solve this equation. You can use any method. I am going to use the elimination method. Okay? So let us multiply equation number 3, multiplying equation 3 by 3. I want to make the coefficient of v equal in both the cases. Here the coefficient of v is 3 and here the coefficient of v is 9, minus 9. So let me make them same. So LCM of 3 and 9 is 9. So here this 3v, we have to make it 9. So I have to multiply this 3v by 3. That's why multiplying equation 3 by 3 and equation 4 by 1, because it is already 9. we don't have to multiply with any other multiples, so I have multiplied it by 9. Now this is multiplied by 3, so it will be 6u, 2v, 2u will be 6u, 3v will be 9v, equals to 2 multiplied by 3 is 6. Similarly, this will be written as it is because it is multiplied by 1. So it will be 4u minus 9v equals to minus 1. So the coefficient of v is same in both the cases and the signs are opposite. Remember, I have told you, when the signs are opposite, then we have to go for addition. So right here, by addition. So this 6u plus 4v will become 10u. There is no change of sign, as you all know. The sign changes during subtraction, but since we are doing addition, the sign will remain as it is. This plus 9v minus 9v will be cancelled, and 6 minus 1 is 5. So u is equals to 5 upon 10, that is u equals to 1 upon 2. Now what is u? I have taken u as 1 upon root x. So in place of u, I can write 1 upon root x equals to 1 upon 2. I have changed u into 1 upon root x, as we have already taken u equals to 1 upon root x. That's why in place of u, I have taken 1 upon root x. Now by reciprocal, root x equals to 2. Both will be changed. This will, the reciprocal of 1 upon root x is root x, and reciprocal of 1 upon 2 is 2. Now if we square both the side, then what we will get? We will get x equals to 4 by squaring. Okay? By squaring both sides. So we have got the value of x. Now we have to find the value of y. Let us replace the value of u in any one of the equation. Let me replace the value of u here. So replacing or substituting u in substituting u, we get here 6u. So 6u means 1 upon 2. So 1 upon 2 plus 9v. V will remain as it is. We have to find v equals to 6. So 6 and 2 will be cancelled. It will be 3 plus 9v equals to 6, or 9v equals to, this 3 will go that side and it will become 6 minus 3, that is 3. Therefore we can write v equals to 3 upon 9, or we can say v equals to 1 upon 3 by cancelling. Now if v is 1 upon 3, we have taken 1 upon root y as v. So in place of v, we can write 1 upon root y. Since 1 upon root y is equals to v, we have taken this. Now by reciprocal, this will become root y equals to 3, and then by squaring both sides, we will get y equals to, this is square is y and the square of 3 is 9, by squaring both sides. So we have got the values of x and y both. So in this way, if a linear equation, if a equation is not in the form of linear equation or pair of linear equation, then we can convert this by replacing with suitable alphabets u, v. You can take anything other than x and y. You can take anything. You can take a, b, c, d also. No problem. Understood? So one more sum, little bit harder, little bit, not so hard. Hope you have understood this. Okay. Next equation is 10 upon x plus y plus 2 upon x minus y is equals to 4. This is equation number 1, and 15 upon x plus y plus minus 5 upon x minus y is equals to minus 2. 10 upon x plus y plus 2 upon x minus y equals to 4, and 15 upon x plus y minus 5 upon x minus y equals to minus 2. Now here also the same thing is there. The equations are not in the form of pair of linear equations into variable. Now see the similarities. Here also in the denominator is x plus y, and here also it is x plus y. Similarly in the denominator is x minus y. In the second equation also the denominator is x minus y. So what we are going to take, let 1 by x plus y equals to u, and 1 by x minus y equals to, so this time I am not going to take u, let me take p, small p, and here it is small q. Okay, we can take any letter from the English alphabet or anywhere. So now this equation, this 10 upon x plus y can be written as 10 into 1 upon x plus y, but this 1 upon x plus y is p, so we can write this as 10p. This will become 10p. Similarly 2 upon x minus y, but 1 upon x minus y is q, so it will become 2q. Therefore the given equation becomes, the first equation will become 10p plus 2q equals to 4, and the second one, this will be equation number 3, this is number 2, and the second one will be 15p minus 5q equals to minus 2. 15p minus 5q equals to minus 2. Now let us multiply this equation number 3 with 5 and equation number 4 with 2. Why I am multiplying this with 5? Because here it is 2q and in the next equation it is 5q. So LCM of 2 and 5 is 10. I have to make them 10. So 2 will be multiplied with 5 to make it 10. Similarly 5 will be multiplied with 2 to make it 10. Actually I want to make the coefficient of q equal in both the cases. So multiplying equation 3 by 5 and equation 4 by 2. So this will be multiplied with 5. This will become 50p plus 10q equals to 5 4 is the 20. Similarly this is multiplied by 2. So 15 into 2 is 30. 30p minus 10q equals to minus 2 into 2 is minus 4. Now as you can see, the coefficient of q becomes equal in both the cases and they are having opposite sign. So again we have to go for addition, by addition. So this 10q cancelled, 50p plus 30p is 80p and 20 minus 4 is 16. Okay, so we can write p equals to 16 upon 80, that is 1 upon 5. Now let us let me replace the value of p in any one of the equation. Let me replace the value of p here, okay, in equation number 3. So substituting the value of p in equation 3. So equation 3 is this 10p. 10p, what is p? P is 1 upon 5. So 10 multiplied by 1 upon 5 plus 2q. Q is not known, so it will remain as it is, equals to 4. So this will be cancelled. 2. So 2 plus 2q is equals to 4, or 2q equals to 4 minus 2 is 2, or we can say that q is equals to 1. So we have got the values of p and q both, but the question was not to find p and q but to find the value of x and y. See this. So we have to replace the values of p and q again to check what we are getting. Now what is p? So what is p? P is actually 1 upon x plus y. So in place of p we can write 1 upon x plus y. So 1 upon x plus y is equals to 1 upon 5, or we can write x plus y equals to 5. This is equation number 5. Similarly, what is q? Q is 1 upon x minus y, as we have taken earlier. So we can write 1 upon x minus y equals to 1, because q is 1. So 1 upon x minus y is also 1. So here in the bracket we can write, since 1 upon x plus y is equals to p, and here since 1 upon x minus y is equals to q. Hope you are getting it. Now by reciprocal x minus y will be 1. So this is equation number 6. Understood? Now we have to solve x and y. They are in the form of linear equation. X plus y equals to 5 and x minus y equals to 1. We can go for addition or we can go for subtraction, anything, because in both the cases the coefficients are same. So let me go for addition. By addition, so by addition what will happen? This y will be cancelled. So x plus x is 2x equals to 5 plus 1 is 6. That is x equals to 3. We have got the value of x. Now if we replace this value of x in this equation number 5, substituting the value of x in equation 5. So what we will get? X means 3, y we don't know, equals to 5, or we can say that y is equals to 5 minus 3, that is 2. Therefore required solution x equals to 3 and y is equals to 2. This is the answer. So a pair of linear equation, if it is not in the form of pair of linear equation, we can easily reduce them to pair of linear equations. Then we can solve them by any method, either substitution or elimination or cross multiplication, whichever is comfortable to you. The method which is comfortable to you, do in that method. There is no hard and fast rule to use any particular method until and unless it is mentioned in the question paper. So hope you have understood. So let us meet in the next class. we'll learn something more about pair of linear equations. There are a lot of situational problems, very important. So we'll do few problems from there also. So have a nice day. Goodbye.